So, oh, good. Michelle is on now. Michelle, I'm looking at the mailing list. I tested the TST. It appears to be working. Is that your?
Yeah, I guess it like automatically updated to a premium account for groups.io, and one of the infra guys confirmed that had taken place. So it should have the proper domain now when you send out messages from it.
Good. So Gabriel, did you get the TST test message?
Yes, I did get an email. Just like a couple minutes ago.
Good. Okay. So what you're seeing here is the control page, the portal to set these up and so on. And you'll see that the members in these groups, main is sort of ignore that. That was sort of the root. So announce dev and TST are up. They have an initial set of members. Their visibility is public. I hope what that means is that anyone can join them, because that's the intent. We're going to use the TST to propagate information about TST activity. So it's not strictly the TST members that are on that. That's just the bootstrap of it. If someone wants to confirm that they can join one of these lists, that would be great. Otherwise, we are slowly but surely getting the infrastructure set up. All right, so and these are mailing lists. So notice that the name of it's list.etherproject.org, and there's a web page that you can go to. So the history is all there as well. Is there anything else transition worthy to talk about? So kind of jumped right into the agenda here, because I had just learned for myself that these lists were up. Is there anything else that belongs on the agenda today? I know we have a planned presentation from Canonical. Is there anything else that we want to make sure we get to, or so we jump right into it?
Larry, from QA perspective, I am currently working on integrating UE ransom, which is a non-Dockerized version of UE ransom. So mostly by tomorrow, I'll create a new PR for the same.
So you think by tomorrow you'll have the next pull request? Did I understand correctly?
Yeah, by tomorrow we will have a new pull request.
Okay, great. For some definition of tomorrow, considering that you're 12 hours-ish ahead. All right, that's great news. So just a recap there, we had been struggling to get UE ransom working in a container, but it's now just running as a separate process. And Canal has it working, and I've just asked for a couple tweaks to that to get it integrated into the Ansible playbook, so it'll look just like all the other on-ramp pieces. So we'll talk about that next week. Hopefully it'll all be done, and we can just announce that it's there. Is there anything else? All right, so let me stop sharing, and I don't know who's going to take the mantle from here, but please do. Thank you.
All right. Is my audio clear? Can everyone hear me?
Yep.
Okay, good. So hello, everyone. We over at Canonical have been working with SD Core for a little bit. I'm sure you've seen us coming in and start doing things, and we thought it'd be a good time to just sort of share a little bit about what we've been up to and what it is that we're doing. So I would like to first introduce Serdar, in case folks haven't met him before, as our product manager in the telco team. And, or sorry, within the telco division at Canonical, I should say. So I will like to turn it over first to Serdar to give a little bit of an overview of, what exactly the ecosystem looks like, and then I'll be doing just a little bit of a overview or demo type of thing, and certainly feel free to ask questions as we go along. So Serdar, would you like to take over now? Or do we not have audio from you? Sorry, Serdar, are you there?
Looks like he's on mute. I don't know if he's there.
Okay, well, while we wait for Serdar to see if he can get audio, we'll just give a brief bit of an overview here. I'm sure everyone is familiar with the SD core. This is the part that we have been looking at in particular right now. We're going to be looking towards the RAN and other aspects of Aether as we go forward, but this is the area where we've been focusing. So as we all know, there's a bunch of different moving parts and communications that go on between things with all of the different interfaces. And it can be quite complex to make sure that you've got it all laid down and configured correctly and everything. So what we've been looking at is automation. The idea being that the system administrators or personnel who deploy these things can run things much more smoothly and achieve a functional mobile network in a shorter period of time. So this could be anywhere from students working on a research project who really aren't interested in the technical details of how the microservices work with each other, and get them more, okay, here's a quick bootstrap to be able to get things started and be able to use things. So sorry, I see Serdar had mentioned, oh, sorry, he's going to try and join again. Okay. So from this, Canonical has been working on an automation solution for deploying and managing open source software. Specifically, in this case here, we have been looking at the Aether project. So brings three main components together. Aether itself, obviously, Juju, which is an automation and orchestration management engine capable of performing day 0, day 1, and day 2 operations. Code for your services are basically software operators. So when you go to deploy a Juju charm, it is not just the workload, it is also configuration scripts or other automation scripts to be able to make this software work in your environment. So a Juju charm, when it runs, it will actually run, in the case of Kubernetes, as a dedicated container in the same pod. For those of you who are familiar with terms sidecar containers, it's like that. So it's going to run in the same pod, and it will be able to communicate with the services running, configure them. In the case of Multis for the UPF, configure the network annotations for you. And lastly, any CNCF compliant Kubernetes cluster. So charm is basically a little piece of operational code. So we write the operational code to operate on the microservice. If you're interested, we've got some QR codes for you to scan and look at to describe the Juju operator framework. And then what we do is we build from the upstream sources the exact same BAS and AMF and UDR, all of the open source software projects. We build them using Rockcraft. So that is again, we got the QR code for here. And it contains the microservice software along with all of its dependencies as an OCI compliant image. The difference between a Rockcraft build and the existing Docker builds is the whole concept of, the staging layer where you're going to insert your GCC compiler and all your tools to be able to build the binary or Golang or whatever. Rockcraft makes it extremely easy to be able to have those things staged, and only the smallest binary required comes out the back end of it. There's also been work involved in what's called chiseling some of the layers that go into Rock. So in the case of like a libc library, it can be chiseled down so that only the components that you need are present, reducing the attack surface as well as reducing the size of the image. Lastly, all of the services that we write are observable. So what we've got is a set of open source software components from an observability stack, which is Grafana, Prometheus, and Loki. So out of the box, that means any of the metrics that the services provide can be exposed directly to this observability stack. The deployment of this observability stack is also automatable through Juju. So this entire software suite is something that we integrate with other products from Postgres or Kafka or whatever the different services you have are. It is easy to plug that into the observability stack and start observing your metrics right away. So what does charmed Aether 5G core look like? Well, we can write these software operators to manage the deployment of all of this, and these individual services have had charms developed for them that will allow the automation of the deployment of Kubernetes platforms as well as the management of their software lifecycle. So in summary, basically a Juju operator and the operator framework allows us to develop a charm as an operator for each one of these services that will then be deployable on any Kubernetes infrastructure that is CNCF compliant. And we also create an OCI image for each microservice that has been specifically stripped down to try and be the smallest possible. Deploying the core network is as simple as a simple command once Juju is installed. Juju deploy SD core Kate. So this is what we call a bundle of services. So it's basically a bunch of services that come together. So what I would like to, there's one additional thing before I start doing some more, doing some of the hands-on demo. That is, so deploying Aether, you can either deploy it as an all-in-one bundle. This can run self-contained inside of a VM and can be used for small proof of concepts or research projects or whatever it is that you want to do. You can make it nice and small, or we can then start going to a proper the control plane, user plane separation, basically, where we deploy the software for the control plane in one cloud and deploy the user plane in another cloud. So that essentially is what, I'm sorry. There was one other thing that I wanted to highlight. So remember I talked about charms having relation interfaces. So we in Canonical have a couple certificate operators that can be used in a charmed ecosystem. Self-signed certificates and a more production-grade vault operator. In the case of small one-off deployments, proof of concepts and whatnot, we would use self-signed certificate operator. What that means is when the AMF starts up, and it wants to communicate using the HTTP interfaces of any of the other services, What it's going to do is when it first starts up, it's going to communicate with a TLS operator. This TLS operator can be the free self-signed certificate operator. It can be the Vault open source version, or it can integrate with a commercially licensed enterprise vault that you may have. The interface is the same. It is merely a matter of saying, this is the provider that I want to use for my certificates. So when every one of the microservices start up, they communicate with a certificate operator to say, okay, I need a certificate. And that certificate is what's used to encrypt the HTTPS connections between all of the services. Same thing with our observability. Each one of the components is capable of communicating with a Grafana agent for providing metrics to Prometheus and logs to Loki. So I'm going to give a bit of a demonstration now. This is sort of the overview of what we've got. I've got one main computer that's going to be my Juju controller. I have another server. These are all VMs that I'm running. I have another server that is the control plane with a Kubernetes cluster on it, and these services are deployed there. And then I have a third server with a user plane Kubernetes cluster on it. So let me start by showing you, sorry, I lost my window here. Here it is. Okay. Is this coming in front? Actually, let me just stop my screen share here. Okay. So here I have my control plane server. If I do a kube control get all the pods, I can see, okay, in my control plane, I've got my web UI, I've got Mongo running, I've got my services, the AUSF and whatnot. But let me just control plane, make this a little tighter here. You'll see we also have the Grafana agent and that self-signed certificate operator that I was talking about, as well as traffic as a load balancer. So, or basically a front-end dispatch.
Mark, you want to save questions to the end, or?
Oh, no, please.
Well, I mean, this has come up several times before, but the observability, it's interesting here. You have an agent that you wrote that knows the particulars of how to get data out of the core.
No.
And that's what you've launched here, or am I misunderstanding?
Yeah, so the Grafana agent is the central point for being able to have the Grafana metrics go towards the centralized Grafana server that's collecting the.
So it's the outpost of the centralized thing. Then my question really is about how did you, I mean, you had to write a piece of code somewhere that understands where to find the interesting data to pull.
Yeah, so maybe I can speak a bit to it. Each of the charm code in each of these network functions, so the charm for the AMF, the SMF, the NRF, so they will have a Prometheus part that will tell which port is used for metrics observing. So Grafana agent will scrape metrics from each of those that do provide metrics. So the AMF, SMF, and UPF do have those endpoints. That's for metrics.
Okay, so if the microservice has already been instrumented and it has a port that it's known to be publishing data on, that's where you're grabbing from. And,
that's for
the
metrics.
charm
For logs,
configures it.
For logs, it's even more interesting because all those services already send logs. So without and Mark may speak to this later, but without adding any additional instrumentation, you'll be able to see logs in a central manner for all of your services. So this is really critical for observing.
So one of the things I noticed then, as a consequence of that design, you don't have the metric func, because your Grafana agent replaces the metric func as a centralization point.
Correct.
Good, thanks.
But just to clarify, this Grafana agent is actually Grafana agent is a Prometheus kind of like that is scrapping data from the different network functions.
It is a Grafana agent. You will, in our observability stack, there will be an actual Prometheus that will scrape Grafana agent. So we do this so that not all of these network functions, all they need to interact with is this Grafana agent thing instead of something that is external. But this Grafana agent will be scraped by an actual Prometheus.
Okay, thanks.
So I will just show here, we have a separate namespace right now that is running the actual Grafana Prometheus Alert Manager and Loki. So those are services that I happen to deploy here as well, just for convenience. The observability stack can be located in any any Kubernetes cluster. It does
Oh,
not.
so COS is centralized observability stack, is that?
It's canonical observability
Oh,
stack.
I'm sorry, centralized canonicals. Yeah, okay, thanks.
But here it's the model name. You could call it banana. It doesn't
Sure.
matter.
But the name of it does give some intent. Yeah, thanks.
Yeah.
So then, sorry, one other thing, just wanted to point out, if I go over to my user plane here, I can see that the Grafana agent is also running there, and we have the UPS service running here as well. So what does that look like in Juju? So Juju is a model-driven approach to software, and it works well with products like Terraform, where you can have a declarative environment and say, this is what I want things to look like. So I can say, okay, first of all, Juju, show me what models I have. So I have modeled the control plane, I have modeled the observability stack, and I have modeled the user plane. So if I say Juju Juju status, this will show me the status of the control plane model. It has modeled these applications, an AMF, an AUSF, the Grafana agent, etc. And then for each one of those applications, there's the actual deployment unit itself. And these would translate to pods within the Kubernetes cluster. At some point in the future, once we start looking at being able to have, like say, for example, the AMF with the load balancer that they were talking about from Purdue, you'd be able to scale applications and say, oh, I want 2 instances of the AMF, or I want 3 instances, or I want 0 instances because I want to turn it down, but not destroy the model because I want to bring it back in a moment or on a moment's notice. So what I was going to show here next is basically, I've just got UE Ransom. Everyone should be familiar with UE Ransom from some of the upstream work that's been going on. So, I'm sorry. Jobs. Oh, I already had it running. Okay, so I will start my GNodeB up here, and you can see, okay, it has established an SCTP connection. You'll notice that this IP address here isn't showing up for the AMF. It's got an internal IP address, right? If I go over here and I say, give me everything in the control plane, what the charm is actually able to do, recall services. So what the charm actually is able to do is it creates the load balancer service port for us automatically. So as part of the deployment, the charm says, well, I need an SCTP load balancer port, and it gives us the IP for that. So, 201.52. Yeah, sorry, there it is. So you can see there's the SCTP connection.
Mark.
Sorry, go ahead.
Quick question. So regarding the external address, but I guess that is something that you're going to configure somewhere. You got to tell Juju that is going to be the external address, right?
Yes, it's part of the load balancer. In this case, I'm using Metal LB. It's part of the relation between Juju and the Metal LB. So it's going to be requesting, ports from Metal LB and IP addresses and such. So yes.
Okay.
So here, if I scale the AMF application down to 0, Oh, there we could see, sorry, there was a little change here. Let me just go back into watching the Juju status. So here we can see the AMF is tearing itself down. I'm going to leave the radio running, and we'll see basically once this thing goes the rest of the way down, it'll lose its connection, and the terminated executing. Okay, session AMF has been terminated. And if I take a look at the services, I can see my node, my cluster load balancer IP has been released. The AMF is no longer running. So if we go back here and we scale the AMF back up to 1, what I'd like to point out here now is we're getting a little bit of history going on what's happening. Okay, so it's initializing the pod, installing the sidecar charm software so that it can operate on it. If I continue to watch our cluster, oh, it's already created the node port. And now you can see waiting for the AMF database to be available. So earlier I mentioned there's relations between units. I mentioned that we have the relation with the self-signed certificates. So that way, when a pod starts up, it is going to request a certificate. And you can see right here, waiting for certificates to be stored. It just went and redid the signing of the certificate so that it can establish HTTPS. Now you may ask, but didn't it already have that? Yes, but we actually rotate the certificates and the database connection every time the app restarts. So it's not reusing old certificates. And when it goes to connect to the database, the relation interface for communicating with Mongo says you are going to receive a point-in-time set of credentials to talk to Mongo. And those credentials will be valid for that session run only. And they are torn down and destroyed when the unit stops. So now that I've scaled this back up, we can see, okay, I can go ahead. Yep, I can reconnect here. And then we can go ahead and start a UE up and we can see, oh, great, I've got an IP address. So if I were to go to the dashboard, this is the same dashboard that we normally see. This is actually coming through the Grafana interface now. So we've just simply replicated the same existing dashboard. But here is where it gets interesting now. If I take a look at, and this is something, sorry, I should do one quick backtrack, and that is, when you are working with charms, there's a concept of a stability track. Right now, what I'm showing is in the beta track. So at the end of this, we'll be giving a link, if anybody wants to try these things out, you can try out our beta release. We also have an edge track, which is the equivalent of our main line of development. So what I'm about to show is actually in the edge track, but it should be landing in beta relatively soon over the next little while. So this is what Guillaume was referring to earlier when he said about central log management. All of our logs are coming in, and I can go filter by, oh, I just want to see the AMF, SMF, and PCF interactions. So I can now go back here and follow the log of the UE connecting through the AMF. Here I can see, oh, this is where the SMF comes in to the PFCP interface. If I add the UPF to this mix, we will then be able to see some of the PCFP messages. I'm sorry, there's just so much chatter now with so many log messages. But you'd be able to see the UPF's PCFP messages. So you can actually go through and pick out very specific things that you want to see logs for and trace what is happening. This, centralized logging is an extremely, it came free of charge, basically, because the observability stack was there. And we have these charms that are capable of relating with an observability stack. One more thing to point out about this is there is also Alert Manager in here. Now, we haven't done anything with alerts, but with all of this set up, it is very easy then for somebody to take this as a research project and start doing things like queuing on alerts of, okay, my uplink throughput has now reached 200 megabits per second, and I happen to know that that's the capacity of this UPF. Maybe I'd like to scale up an additional service somewhere else, or things like that. Predictive analytics, whatever. Like I said, I'm not in that space, so I don't really know a lot of what would be interesting. But the idea is we want to take away the, oh, how do I configure it? How do I get it running? And let people concentrate on what can I do with this now that I have the information. For a configuration perspective, I am going to just switch over to my user plane bundle. And here we can see the configuration, for the UPF. And in here, we can do things like enable hardware checksum. I can toggle that on or off through a Juju config UPF. Enable hardware checksum equals false. And what will happen is Juju will go off, wake up the charm. The charm will look and see, aha, we've had a parameter change. Let's go ahead, reconfigure that UPF to match what's there, restart the service, and it'll be up and running. So if I went over to my control plane here, we should see, yeah, the UPF is in the process of restarting right now. There are different things such as the UPF mode. You can switch it from AF packet to DPDK relatively easily. You can configure like the DMN name and things like that. So we only chose a few things to be able to expose in here. But eventually, once I learn a little bit more about what makes a UPF tuning tunable, we may look at start exposing some more of the UPF JSON configs. Okay. With that, I would say that this pretty much concludes the demo. I will flash up, where is it here, our documentation slide. Is there anything else that I can cover? The other thing is, of course, this is all open source software. It's all being developed free and clear. We're not charging for this. This is like the Ubuntu operating system. You know, is Canonical coming into an area and basically making it easy to consume open source software for other people.
One question, Mark.
Sure.
You guys mentioned that basically each of the individual network functions basically exposes metrics, right? Even the logs. Is there any change to be done in the different network functions, or how this is being exposed? Is this kind of like something that when specific port that you need to expose on the different network functions?
Well, right now, not all network functions expose metrics, only the UPF, SMF,
Right,
and AMF,
exactly.
and we leverage those. For logs, however, all network functions expose logs. So our service manager that will start and stop services is called Pebble, and Pebble has the capacity to forward logs to a low key, and we leverage this. That's how we get there.
Mm-hmm.
In terms of metrics, we're very much interested in having more metrics. I mean, some network functions I think could present more metrics. Like I think WebUI around the number of I'm sure a bunch of them could have more metrics, and we would leverage those as soon as they're available. For sure.
Oh, okay, but basically to be able to enable metrics to the other network functions, so to be able to expose the logs in a centralized manner, you need to do some type of port exposure or something like that, right?
Well, for metrics, yes, one service needs to be serving metrics, like it's a
Mhm.
Prometheus client, and that's
Right.
we're not adding something here. This is already in the option. That's already in the AMF UPF.
Yeah,
so
for
that needs to
AMF,
get-
SMF, and UPF, there is already there the
For logs,
exposure.
it's different. Logs are being pushed from the workload to a low key, so no additional ports
Oh,
need
okay.
to be opened there.
Oh, okay. Thanks.
So this is great, Mark. I just put a spot in the minutes asking for you to give links to anything that you can. I know you've got the I didn't actually see the URL. So, you know, for the slide deck, for the source, a pointer to the source code, a pointer to the documentation. I know you had the QR codes, but just so that we can
Yes,
capture that in the notes.
yes, absolutely.
Yeah, thanks.
Sorry, what you see
So is
here,
there,
sorry, go ahead.
the line's a little blurry, but nothing in that you've done in Charms gives you a runtime control interface. Is that the right interpretation? Is a configuration so that you can deploy it in the right way, and then you can, of course, scrape metrics and logs and so on. But in terms of a runtime control interface, that's not part of the Charm Juju story, if I'm understanding correctly.
What do you mean by the runtime? So do you specifically mean the rock in the context of Ether?
Well, so what an Ether is the rock now. I was wondering if there's an equivalent version of that.
Yeah, well, we built a front end to be right in front of the web UI component, and this is what we see right here. And this can be leveraged to create network slices,
Okay, so-
subscribers. So yeah, this is how you would configure your network. Correct.
Got it. So it shows you, it basically is mirroring whatever web UI gives you.
Absolutely. It
Yeah,
will
got
improve over time. Like right now, there's no authentication or anything on it. This thing will improve over time, but it's very thin. It's meant to be really thin in front of web UI. Yeah.
And again, the idea being here is that we are using Kubernetes, like Metal LB or other load balance services. We're creating load balancer ports so that when you go to connect to the NMS, you can see here, I'm actually, connecting, well, in my case, I'm happening to use nip.io because I don't have proper DNS resolution at home. Well, my own custom DNS server, but yeah, you can, like, this is actual, Nginx or whatever in front of it. So doing something like integrating with HTTPS. Right now, this is not secure, but we would be able to put the same certificates operator in here and get a proper HTTPS certificate from a real CA for this front end. Can also do things like put in auth proxies and things like that. So rather than building all of that into the code base, we're leveraging the infrastructure as it's intended to be leveraged, to make these things more transparent. In the case of the UPF as well, where is my, oh, sorry, that was my UPF right here. Same thing. If I take a look at the services, I can see that we have a UDP load balancer in front of the UPF for the PCPF PFCP interface. So there again, when the SMF goes to talk to the PFCP agent within the UPF, it's not talking directly to a node port. It's talking to a load balanced UDP IP address, which can then be moved to where, like, basically forwarded by the load balancer to wherever the pod happens to be executing, whatever IP it happens to have. So in the case of an H8 cluster where one node might go down and then it's going to respawn the UPF somewhere else, you don't have to worry about IP addresses or anything like that. It'll all be transparent because we just said create a UDP load balancer. Same on the AMF. We're just saying create an SCTP load balancer. And that, of course, is stateless, nothing like the good stuff that Purdue was doing.
Yep, thanks. Any other questions?
Mark, so for this external UPF, is that something that you guys enabled, or for the external for the load balancer there?
Yes, so basically when the charm and the image start up, what the charm does is it tells Kubernetes, okay, here is basically the services that I want running, and it starts up, BESD with its gRPC server. It then turns around and makes API calls to the Kubernetes cluster saying, I need an external IP load balancer on port 8805. If the cluster is unable to provide that, the charm will put the operational status into a paused or blocked state and basically say, hey, I can't finish exporting the UPF. I can't finish setting up this service because we don't have a load balancer IP that I can use.
Okay, so then let me restate my question then. So I guess in this specific case, you need an external address for the UPF because your user plane is deployed in a different place than the control plane.
Correct.
Okay, yeah.
And the idea being as well is that IP address could be, a floating IP in the case of a public cloud or something like that.
Right.
Yeah.
Oh, okay. Yeah. Cool. Thanks. But okay. So in general, do you guys envision the deployment like two separate entities? Let's say user plane from one part and control plane in a different part, or it could be also everything kind of like how we typically deploy is like everything on the same cluster. Or
right. The idea behind this is that you should be able to start as small as you want, all in the same cluster. And we do have a getting started tutorial where you can do everything as an all-in-one, and it doesn't actually need to create external IP addresses for
right. Yep. Okay.
Yeah, all the way to, you want to be able to try and scale this out to a production scale where, I mean, the whole thing about a containerized UPF for a production deployment is still sitting a little oddly with me. I'm not entirely sure if that's where people want to go with a UPF, or if they would be more interested in, like bare metal UPFs, where you're going to be running this thing on a, piece of ARM hardware out closer to your radio. And that is something that we're working forward to as well. We mentioned charms and operators, and we mentioned that it can deploy to Kubernetes. We're also working on something that we call the machine charm. And what that is it will deploy the UPF software directly to a host server and manage it the same way, but on bare metal instead of a container. And that's where I discovered a bit about the kernel and set processor affinity.
Oh, okay, cool. Yeah, so from the best perspective, it's doable to deploy the best component in the bare metal. And there is Ansible scripts to actually do that direct to help you, so you don't have to handle the dependencies.
Yes.
But that's just for base. And then there is in the UPF itself, which is primarily the PFCP agent. That's where a few things are kind of like mixed up, at least based on the previous way of doing this. So yeah, any feedback, any input is welcome to kind of be able to do all these different improvements.
Certainly. Well, yeah, as I said, we're right now working through some of the details of bare metal BESS. And I can get into the description of what a snap is and how that helps make software as deliverable as an OCI image. So that's something else that Canonical uses is snaps. And I know there's a lot of love-hate for snaps out there in the world in terms of, well, Flatpak versus snaps, and snaps aren't as user-friendly and so on. For in this case here, what we're talking about is packaging up everything that's needed to run BESS and PFCP and route control and everything in this snap. So that way, when you deploy it, you get all the software that you need in a namespace and immutable file system. So it's delivered as an immutable file system. Of course, there's a config where it can store its configuration stuff, but we deliver UPF binaries in that way, basically. I don't know, Guillaume, if you wanted to jump in about the snap a little bit there, because you've been looking at that recently.
I can, but we've already taken a lot of the meetings.
Oh, yes, sorry.
Do we want to continue on this topic, or?
Let's see if there's other questions. I actually have one, which is, how do you, this is sort of orthogonal a little bit. I'm just curious how you do testing. What simulator, what workloads do you put on the core?
Yeah, well, there's a couple of levels to this. Like most of our efforts here is related to the operation code that we write. So so we test that. So let's say we talk about deploying, upgrading, scaling, integrating, all that stuff. We test it with unit and integration tests.
Right.
Now for end-to-end, to make sure that our stuff works end-to-end, we deploy what Mark just showed via Terraform, and we deployed a Genode BSIM, and we run a simple end-to-end test. So we don't.
So you're using the same GNB sim that we are using.
Yeah.
Then.
We plan on.
Got it.
That being said, we plan on switching to UE ransom, but it's the same purpose. Like at the end of the day, we want to make sure that we haven't broken anything.
Got it. Thank you.
Yeah.
Just kind of one heads up, since you guys are going to start using UE ransom, it is an inactive project, just in case. Even though the developer is accepting contributions, but the project itself is inactive. That's one comment. The second one is it doesn't necessarily handle all the different cases. I don't remember specifically what was the situation. That probably, I think it was last year. When I was running some tests with UE ransom, when there was disconnection from the, I don't remember whether it was the Genode or the UE, probably the UE. The UE ransom didn't handle those kind of situations. Compared to OAI, it did handle those situations. So just kind of be a little bit cautious on that in the completeness on UE ransom.
Okay, thank you. I wasn't aware it wasn't being maintained anymore, so it's good to know.
It is inactive since probably last year or 2 years ago. But the author is still accepting contributions in the case that you want to contribute, but there is no activity from the primary developer.
Who is
and we'll
that?
see what we.
I always thought it was AJ. Is it not?
The UE ransom?
Oh no, not UE ransom. GNB sim.
Oh, GNB sim is a primary AJ. Yes.
Yeah.
So, but
I'm sorry,
GNB
I get
sim
confused. It's UE ransom. That's not.
Yeah. No, I'm talking about UE ransom.
Sorry,
GNB sim, that's
confused.
something that is part of the OMEC project on the SD core itself, and we are continually doing the development of that.
Thanks.
Okay, so just to be clear, right now we're not doing all of the functional tests that you currently do using Genode B that you're currently doing in your pipeline. We're trusting that your pipeline is covering all those spaces, and right now we're just doing essentially sanity to make sure that what we've compiled is what we thought we've compiled, and that it works on a functional basis. So we've not invested heavily in a whole bunch of different automations and things like that. Definitely want to look at the Genode B sim profiles and start getting some more of those into our pipeline, but we're not there yet.
Yeah. No. That's understandable. But I just wanted to kind of highlight this about a UE ransom, just so you guys are aware of that.
Yeah, I've also been following Packet Rusher, what that fellow from
HP, I believe it is.
HP, yes,
Yep.
from
Mhm.
Hewlett Packard, yeah. So I'm interested to see where that goes and see if that's something as well that can be incorporated.
Mhm.
Not sure, basically upstream first. As well as I've been interested in when you start doing some of the performance test things,
Mhm.
dusting some of that off and getting that running as well. The pipeline or the environment that we have for running our tests is virtualized. So of course, we probably wouldn't do any performance testing in our pipeline because that's not the point of it. But it would be good to, understand how it's done, how we can incorporate it if we've got anything, where it's like, okay, well, how do I make it easy to do a performance run? That's where I start, picking up my ears and going, okay, how can I make this easier to consume?
Mhm.
So Mark, I'm sorry, yeah, Mark, can I jump in? We have just a couple minutes left. I'd like to wrap up with a couple of the things. Pick this up again next time if there's more. Just real quickly, because we're coming around to the end. Thank you very much. That was great, and I want to get all of this documented so we have all the links to everything. Just because it's where we're going to be doing our communication. I believe it to be the case that if you go to this URL, and I'm using TST as an example, but you could do this for Dev as well and announce. This is where you can get access to the mailing lists. I believe if you aren't already a member, you'll be given an opportunity to join, I believe. Someone should test that out for these mailing lists, and I will post an announcement so everyone else can do that as well.
Okay, and to confirm, subscribing to the TST is not restricted to TST members only.
Correct, correct.
Anyone
All
who's
Dev,
interested.
Announce, and TST are all public and open.
Okay.
And
Larry,
yeah.
sorry, I just observed, I went to the root of that URL and it also looks like there's a main list or something that one can subscribe to.
Main, I understood main to be just an artifact of, you had to have something to start and then everything forked off of that.
But since
we
it exists,
were not planning to use main, so I would let's ignore that for now.
okay. Otherwise, it seems to be working, or from what I can see so far. Good.
So did you join something?
No, just looking at at least the opportunity to join. I'll join.
All right, so I will, yeah, I'll be posting this for everybody else that doesn't attend these meetings, and we'll try to get people to start using these mailing lists.
Okay, so to kick off the mailing lists, where should I post like we're going to be having a blog post coming up about the beta release and things like that. It's something that I could have Serdar send a message to. Yeah, I don't know if you would want that going to TST, or is there a better place for that?
Well, I would think that would be a good thing to post to Dev, because developers would
okay.
be interested in it.
Perfect. And as well, following up on performance testing, an action item to start a email conversation about that. Would that be Dev or TST?
That also Dev. I think,
think
of TST as fairly seldomly used. It's, as a community, we need to make decisions. We need to. I'm kind of guessing that Dev is not. I'm sorry, that TST is not going to be heavily subscribed as Dev will be, or Announce. That's why I'm suggesting those other two.
Yeah. So when I was in OPNFV TSC, what we did there is we used the mailing list for things like offline voting or nominating proxies to attend if people weren't able to meet. But that was much more formal process and whatnot. So I don't think we're quite at that level of overhead needed for.
I hope not. And like we can certainly use a TST as a voting place. That's certainly in scope, but it's kind of, those people that are really active. I mean, if you're showing up to these meetings, and I don't know, a good fraction of you are not technically on this TST, that's the group of people that are most active, that this is a place to
Yeah.
talk about things like that. And get stuff on the agenda for that matter.
Yes, that's a good point. Requesting a slot on an upcoming agenda is a good use of the TST list.
Yeah. And yeah, I mean, announce should be bigger than dev eventually, but we got nobody on it right now. So everybody's homework assignment is to start to figure out how to use these lists, and hopefully we will, and to start posting stuff so we have some content to attract people to join. Anything else? Oh, and just, I guess I put a little bullet down here. If you are using Aether for some purpose, and I said in the lab as opposed to you're doing some larger trial deployment, we're going to play those up a little bit more. But if you're doing lab work, go, and we now have our first entry, so you got something to mimic a little bit. Let's start populating that page. Otherwise, I don't have anything else.
Just one general comment, Larry, regarding the upcoming release. So I start tagging all the different auxiliary repositories that we have so far. So primary network functions are pointing to the, let's say, to the tags or the latest versions of the auxiliary repositories. Probably this week, I'm going to start tagging the network functions themselves that for, in towards the next release.
Great. Let's plan on a serious update of that status next week.
Mm-hmm. Okay.
Good.
Thanks.
Thank
All
you for
right.
this, by the way. This is awesome.
On that note, Mark, and if anyone that from Canonical tuned in, just populate the notes here with with the URLs. All right. Thanks, everybody.
Thank you.
Bye.
Bye. Thanks.
Bye.